Good day, everyone. So, welcome to my channel. This is Teacher Grace, and this is the part 2 video of our lesson, the mole concept. As to recall, in the part 1 video of the mole concept, we have learned there the the units we use for the substance, particles, atoms, and molecules, and that is mole. Okay, and also we have learned there on how to find the number of atoms, also the number of molecules in a given mole. Okay, so let's continue. Before we will continue to our lesson, let us recall first on how to find the atomic mass of an element in the periodic table of the elements. In here, we have, for example, the iron element. We have the chemical symbol Fe, and the atomic mass can be found on top of it. So we have here the 55.845, or we can write down the 55.85 gram per mole, meaning there is 55.85 gram of iron in 1 mole. So, since ready na po ang lahat ng mga materials na kailangan natin sa lesson na ito, let us go now to the main topic. So this time, we are going to learn on how to calculate the number of moles and the number of atoms of a given sample. For example, we will use the element aluminum. So aluminum is a metal with high resistance to corrosion and often used for structures such as high-quality bicycle frames. This time, we are going to compute both the number of moles of the atoms and the number of atoms in a 10 grams sample of aluminum. The sample we are considering has a mass of 10 grams. Its mass is less than 26.98 grams. So this sample contains less than 1 mole of aluminum atoms. Now, take note that the value of 26.98 grams of aluminum can be seen in the periodic table of elements to the corresponding element sample. For example, naalala nyo kanina sa periodic table, doon natin makikita, we can find the value of atomic mass ng bawat element. Okay? So for the aluminum, try to check that in your periodic table. Aluminum has a value, the atomic mass of 26.98 grams. Okay? So, continue po tayo. This time, we calculate the number of moles of aluminum atoms in 10 grams by using this statement, equivalent statement, that in 1 mole of aluminum, it is equal to 26.98 grams. To construct the appropriate conversion factor of 10 grams aluminum from the given sample problem, compute both the number of moles and the number of atoms in a 10-gram sample of aluminum. So the first thing to do is to write down the 10 grams of aluminum as the given value, multiply it by 1 mole of aluminum divided by 26.98 grams. And it is equal, cancel first the unit of grams, and then equal to 0.371 mole of aluminum. Next, we will convert from moles of atoms to the number of atoms using the equivalent statement. 6.022 times 10 raised to 23 atoms is equal to 1 mole of aluminum. So we have 0.371 mole times 6.02 times 10 raised to 23 atoms divided by 1 mole is equal to, we have to cancel first again the units of mole. So it is equal to 2.23 times 10 raised to 23 atoms. Okay, now where did you get the 26.98? This is the atomic mass of the element, and it can be seen in the periodic table of elements. Now, it is your time to compute both the number of moles of atoms and the number of atoms in a given samples. For number 1, 20 grams of oxygen. Number 2, 50 grams of sodium. And number 3, 150 grams of magnesium. Try to pause this video so that you will have enough time to do the task. Okay, time is up. And let's see if your work is correct. For 20 grams of oxygen, we have 1.25 moles and 7.53 times 10 raised to 23 atoms. For the 50 grams of sodium, we have 2.70 mole sodium and 1.31 times 10 raised to 23 atoms. For the last example, we have, and for the 150 grams of magnesium, we have 6.17 moles. And it is also equal to 3.71 times 10 raised to 24 atoms. So, you did a great job. Thank you for watching. Hope you learned new lesson today. God bless everyone. Bye-bye.